It'll. No, you have to unplug and replug.
Let's see if it's
because Mac.
there.
Woo. Oh, that actually looks. You can see the yellow.
Yeah.
Hello, everyone. Welcome to the Banana BOF. Banana stands for bandwidth aggregation for network access. Nah. Because you can't just have a banana. You have to have a banana. Bandwidth. Oh, that works. Bandwidth aggregation. Okay, so we have a multiply expanding acronym for this working group, which might be actually one of the first ones we've done here. So I'm Brian Trammell, BOF co-chair. This is Margaret Cullen, BOF co-chair. Oh, and I did the name wrong. My apologies.
I also spelled my old name wrong. Only one.
Oh wow! And I was up here complaining that nobody spells my name right. Okay, embarrassing. So I will. I'll keep an eye on the Jabber room. If we could also have another Jabber scribe. I see a hand, and it's Aaron. Excellent. Thank you, Aaron. Thank you, Tommy, for taking notes. So let's go ahead and get started. This is a BOF. This is the Note Well. It is Thursday. Hopefully by now you've seen it at least once. If you have not seen this, then actually go have a look at 5378, 3979, 4879. They describe your rights. Anything you say in here is a contribution to the IETF and can be used against you on the mailing list. We have a pretty quick agenda today. Margaret's going to go through the problem description. We're going to have 3 presentations about the solution space and experience with things. We have 2 presentations on deployment experience and an overview of one of the proposals in this space. I'm then going to get up and talk about some research that we did at ETH with Swisscom on an alternate approach to this. We're going to talk about overlap with the problem space here with other SDOs. So Dave Allen from Broadband Forum is going to come have a talk about that. Then we have 30 minutes to figure out what it is we want to do here. If there's interest, if there's work, if there's some way to go forward. And then 10 minutes where we're going to look at the following questions. I do actually want to preview these. Think about these as we have the discussion today. Do we have a clear problem statement? Is it well scoped? Is it solvable? Is solving it useful? Is there work to be done here within the IETF? Is the solution to these problems are these IETF solutions? Are there people in the room who are interested in working on it? And then the fourth one is not going to be a clear humming question. This is going to be an open what next question. Are there other working groups that should be working on this? Should this happen in its own working group? If we come to the end of all of these questions and there looks like there's a new working group here, then we'll be soliciting volunteers to work on putting together a working group forming BOF for Chicago. So think about these. We'll put these back up after Margaret's done her talk on the overview of what we're doing here. So.
We should try to find a Jabber scribe. I don't think.
Yeah, we got Aaron.
Okay, good. All right, well, good. And one thing it would be good to do is try to just have clarifying questions on the presentations and hold open discussion until the open discussion period.
Yep.
And that's mine, which is over here. Where is it?
First one.
No, but it's not. I don't know if I just did, but I don't know. Hold on. So I'm actually Margaret Cullen now, but I'm still Margaret. I'm not sure there are other Margarets here, so it's kind of a I'm going to talk about the scope of this BOF and also the problem description that we're trying to work with. Slide. Can I use a clicker I can use or something?
Yeah, I can set that for you.
But the scope basically is that we're trying to do bandwidth aggregation and failover solutions for multi-access networks where the end hosts are not multi-access aware, or at least some of the end hosts are not multi-access aware. So here's a kind of typical multi-access home network in very abstract terms. There's a host or hosts. There's potentially a couple of CPE for a couple of different attached networks, and they go out to the internet, and there's some sort of content that the user is trying to access on the internet. Now today, what happens is that traffic gets sent through one of those two CPEs to reach that content source. So what happens is you either use your default gateway or you use your IPv6 source address selection, and that basically picks a path, one of the two paths, and it ends up going out to that source, okay? But the other path just doesn't get used. It sits there unused. So if you're trying to do a huge file download or some high-speed video download or something like that, you're using the bandwidth of one of your paths, and your other path is not doing anything for you, even though you may not have any other flows or only a very small number of other flows, maybe only small ones. So, and then you also have the problem that if somehow that connection, that CPE, becomes unavailable, you don't fail over to the other CPE. Not this connection doesn't fail over, right? You'd have to go and start it up again. So how can we do better? That's the point of this BOF. There are three different solution scenarios, and we're going to talk about different solutions here, but there are three different ways you can approach this problem. One of them is that you can do a single operator solution, and this is what we originally have been discussing in the banana bar BOFs that we had leading up to this, is a single operator solution. You can only solve this problem when both of your attached networks or all of your attached networks are through a single operator, and then you do something where that operator gives you a CPE that splits the traffic over multiple links and recombines the traffic in some way in the operator network, okay? There's also a possibility of a bandwidth aggregation service in the internet. So I could have two CPE like I did in my first picture. They could be from two different operators, but I could contract with a service provider, a bandwidth aggregation service provider to give me some sort of box or put software on my Wi-Fi access point or something that could split the traffic, and it would go to a server in the sky provided by my solution provider that would recombine the traffic before it goes to the other end. Or we could do an edge-to-edge solution where the traffic gets split at my edge and recombined at the edge of the content provider or whatever site I'm trying to reach. So just to give you a little more background on what those look like. In the single operator solution, we'd have one CPE. That CPE has two links. We send all of our traffic to that CPE. It's our default gateway. It shares the traffic over the two links, as you can see with the green lines, recombines it in some way at the provider edge, and then sends the traffic out into the internet. And it turns out that this is not a very hard problem to solve, but it's very limited, okay? Because you can only combine links that come from a single operator. So if you got your LTE and your DSL from the same operator, you could share those links, but if you got your LTE and your DSL from different operators, or you have LTE and cable, or some other combination, it won't work for you because they're not the same operator. The second scenario is the bandwidth aggregation service scenario. And in that case, you've got a host. He has a couple CPEs from potentially different providers. The bandwidth aggregation service people give you an aggregation tool in your house. It's either an extra box, or maybe it's software on your host, or software on your Wi-Fi access point, or software on one of your CPEs, but another functional piece in your house. It splits the traffic across both paths, and then it's recombined at some big box in the sky. Okay, that big box in the sky could be a proxy or some sort of address translation device. You have a lot of different sort of options for what it does at that point, but basically that's the scenario, is it's recombined in the network somewhere and then sent on to your content provider. Other one is the edge-to-edge solution, and they get progressively harder to solve and more interesting to solve. This one, you've got your home, 2 CPEs, the internet, you got your content source, and this is really the same picture, except I've added another box, which is the edge of your content source. It was always there, but it was left out previous slides. Here you get that aggregation function in your home. It splits the traffic across the 2 CPEs. They go across the internet, and they get recombined at some sort of de-aggregation function, either a proxy or a translator or a tunnel endpoint at the edge of your content provider. So those 3 scenarios we're going to talk about, and we're going to talk about them in terms of some solutions that we have on the table, or even possible solutions that could be on the table. The solution proposals we've been talking about in the banana bar box and on the banana list before this meeting include GRE tunnel bonding. And there's a draft for this. And this is basically, it's been written up as a single operator solution, but it could easily be adapted to a bandwidth aggregation service solution. Couldn't be an edge-to-edge solution without additions. It could be used as the basis of one, but would require more work. It assumes, and basically traffic is shared on a per packet basis. It's put over tunnels, and the tunnels are, they both have the same tunnel endpoint where the packets are put back in order and sent on to the content provider. Or on the way back, they're recombined and sent on to you, right? This has to work in both directions. The MPTCP proxy solution, we're going to talk about a deployed MPTC proxy solution that's deployed at Korea Telecom. So who's going to talk about that? There are also a couple of documents, but I don't think these documents actually match what's deployed exactly. And there has been discussion of possible documents that haven't been written yet. And so this is a work in progress space at this point. And the current work applies to single operator or bandwidth aggregation service. And it also would require some more work to figure out an edge-to-edge solution. There's a lot of certain problems with the edge-to-edge solution. We'll talk about them in a minute. The simple case is TCP only, but there has some work in those documents to try to figure out how to put UDP into the picture in various ways. And multiple options are being explored for that. There's the multipath bonding at layer 3. That's the research work that Brian is going to present. This is UDP only. It's an edge-to-edge solution. It's a bit incomplete. I mean, it was a research project, but it's really promising in terms of what they were able to figure out, and I will leave Brian to talk about that. It's the output of the Applied Network Research Group of the IETF, and it would need work to pair with some kind of TCP solution, possibly an MPTCP-based TCP solution. There's some work underway in the MIP working group, no, the DMM working group on a mobile IP-based technology that could apply to this called MAG multipath binding. This is a mobile IP-based solution. What scenario this is would depend on your mobile IP infrastructure, and I honestly don't know exactly how this could apply exactly to the 3 scenarios I've talked about. I think it's a little bit of a different type of solution. And there's another solution that's been discussed. Dave Allen will mention it because it's been discussed in BBF, and also the documents are up there for you to peruse. This is a bonding solution for hybrid access, and this is a 3GPP solution. It assumes, at least in the current way it's written up, that one of your networks is 3GPP, and it's also single operator. And if there's time, they may do a brief presentation of the solution at the end of the session, but it was not actually published as an internet draft until Monday, so it didn't make the cutoff for our agenda for today. So there are a number of high-level challenges that we have for any solution in this space. Some of them apply more to some than others. The first one is performance. We only want to do aggregation if it's going to be faster Okay, and determining whether or not to turn it on is not an easy problem. Okay, you need to know about characteristics of the links. You need to know about how loaded they are. In some cases, you need to know about their latency. And so that's a tricky problem in this space in any scenario. There's also the question of bottlenecks. The bottleneck may not be the link at your house. All right, so you put on some tunnel overhead or whatever, and it turns out that the bottleneck is somewhere, especially in the aggregation service or edge-to-edge scenarios. If it turns out that the bottleneck is further away from you than that, you may actually get considerably worse performance using this solution, even if it does increase the bandwidth that's coming out of your house, or the potential bandwidth that's coming out of your house or into your house. There's concern with flow control to avoid both buffer bloat and congestion with any of these solutions. It's an issue with this type of a thing. I don't know. One of the things that makes this an interesting problem and not a solved problem when we have ECMP and other ways of doing load sharing is that we're talking about a fairly low number of flows. You know, a typical home will have a small integral number of flows at any one time. Many of them are tiny, doing things like checking for updates, whatever. Some of them are big, like you're watching video or you're downloading a big software package or something like that. And so doing a per flow load sharing really doesn't work in this case, specifically because you don't want your big flows limited to one of your two incoming connections. You actually want your flows to be aggregated across your connections. So that's why this is a little different than what we've done in some kind of like backbone networking type of load sharing cases. There's a bypass requirement. There are laws or regulations or service agreements that require that some traffic transit a particular link. Okay, so your DSL television provider may be required to make sure that your TV comes over the DSL link. All right, they don't want that actually load shared over another link. So they need some way for that data to bypass the bandwidth aggregation. We also have all the usual issues with either tunnels or proxies, depending on whether your solution is tunnel-based or proxy-based. Tunnel issues include packet reordering, MTU issues, etc. So solutions have to deal with those. Proxy issues include dealing with encrypted traffic and end-to-end security, and side effects of session termination in the network. So if you did a TCP session to something that makes an MPT session to something that makes a TCP session, you have the issue that stuff has been ACKed over that first connection long before it's been even transmitted to the end host, and that could have some implications for upper layer protocols. Provisioning, configuration, discovery. This gets harder as you move toward the later scenarios. It's easy when you're all in one operator because they control your CPE and your provisioning. When you move to something in the network, well, somehow that aggregation service needs to know where it is. Maybe that's not too hard. When you move to edge, finding the right deaggregator for the person you want to talk to is going to be a tricky prospect, no matter what kind of aggregation and deaggregation we're doing. And we don't want to end up basically being an easy way to redirect to man-in-the-middle attacks or to have somebody collect all of your traffic. Reverse routing is an issue, right? Because actually what we're really trying to do is bandwidth aggregate things coming down to your house for the most part. It's very important that the reverse traffic also aggregate across multiple links. And there are a couple ways to handle that, either through like an IP address translation or a proxy that does session termination, or some other type of, or the tunneling actually does it by using external and internal IP addresses. Different solutions solve it different ways. There's TCP only versus TCP UDP. The bulk of the traffic is TCP now, so it actually works pretty well if you can just do TCP performance-wise for the bandwidth aggregation. But the amount of UDP traffic is increasing and probably will increase more with QUIC. And also Failover doesn't work if you only fail over TCP traffic and not UDP traffic. Because yes, your TCP traffic can work, but if you're using the failed link for DNS, you're not going to be able to establish a new session over the remaining link. We'd like everything to fail over both UDP and TCP. Security. We shouldn't become a vehicle for man-in-the-middle attacks. We shouldn't break end-to-end security. There's a lot of security implications here. And transition strategy. How do we interact with, I can think of two things that are important here. End nodes that get like MPTCP or some other multi-access mechanism, but also how, for instance, if you had a bandwidth aggregation service installed in your home, that would interact if someone was also giving you per carrier bandwidth aggregation for a couple of the networks that come into your home, if they happen to share a carrier, right? So how these things are going to interact, both it running multi-level and it running with other techniques that might be used to do bandwidth aggregation, including end-to-end as opposed to edge-to-edge solutions. So those are the things we have been thinking about and should be talking about. Anybody have any clarifying questions on these slides?
Hi, Aaron Falk, Akamai. I'm just wondering whether, I was surprised not to see on your list ICMP related stuff that, for debugging and troubleshooting ICMP, ping trace route.
Good thing.
Yeah.
I tried to limit myself to 10, but that would be an excellent number 11.
Pete Resnick, and I'm just sort of trying to formulate here. All of the solutions in this space are something in front of your host to something in front of the other end. And so I presume there's some motivation behind host to other end directly, like MPTCP splitting and then coming into some aggregator at the other end is not on this list. Could you explain the motivation for these models and not maybe some others that are more host-based?
Well, if your host sent MPTCP, hopefully we just send MPTCP all the way through, right? But your host isn't sending MPTCP. Okay,
So this is, we want unchanged host, unchanged destination. What can we put in the middle to help that scenario?
Right, but we don't want it to mess with the transition. Like, we like it if we map into MPTCP, and then if your destination becomes MPTCP aware, but your host still isn't, we would hopefully not proxy it back to TCP before sending it to someone who could handle MPTCP.
And vice versa.
And vice
Host
versa, yeah.
Oh, okay, got it. Thank you.
But how we do that, it's,
Cisco. Margaret, you made one comment on the current solutions. If you can you go back
Sure.
to that slide, please?
It should be a clarifying question only. Comments and discussion should be held until later.
Yeah, you made one comment that
Sure.
essentially.
If I made a correct statement, just clarify it.
Yeah, you're not sure whether it will work in all the solutions, right? I think.
No, I think it has different scenarios. I don't think it maps to the 3 scenarios that I presented, because I don't think mobile IP maps directly to the 3 scenarios I presented.
It does, actually. I think we
Okay.
can have a separate discussion, but
Okay.
I just want to say the GRE aggregation solution is no different from the PIM or the mobile IP based solution. In general, there's no overlay anchor, and there's other end. Essentially, it's doing the link
Okay,
aggregation.
so it's just
the
tunneling,
signaling,
basically.
Yeah, the data
Okay.
plane is the same. Signaling protocol is different.
Okay.
Hi, Margaret. Bob Hinden. So you said, based on the slides you showed at the beginning with the pictures, you don't have to go back,
Okay.
but you said there weren't solutions to this. So I'd like to point you to one RFC published in 2005 called IPv6 host to router load sharing, which solves the load sharing problem. And then there's a draft which is now in auth 48 that's just came out of 6-man first hop router selection by hosts in a multi-prefix network, which to me solved the problem you were talking about.
Well, they pick one router, though.
No, it works in.
They will actually send some packets of a flow over one
Yeah,
and
well,
some packets of a flow over the other.
That's what the
Okay.
load balancing does.
All right, well, I'll
Okay.
go look at it, but
And so you also didn't say anything about
In
is
this-
this V4, V6, both, something else?
I'm presuming both, but because we're stuck with V4. I'd love to be able to say it's V6 only, but that doesn't help us with most of the flows that are out there today.
Well, yeah, but you also have to get, implementation to actually do this. So
I've
think
been
IPv6
believing
would be better.
IPv6 was going to be here in 2 years since I was young, and now I'm a grandmother. So I don't believe, it's good. There's still going to be a lot of IPv4 out there in 2 years, Bob. Sadly.
But you're proposing what I think are a whole bunch of protocol changes. So again, there's a lot of existing work that covers some of this, and I'm not sure, it doesn't sound like it was looked at. Well, the first one is RFC 4311, and the other one, I can tell you the RFC number, it's not out because I'm in auth 48, it's 8028.
Is 4311 v6 only?
Yes.
Okay.
Sounds like 8048.
It's got multi-homing in it, and it's a 6-man draft. Yeah, so.
IETF 6-man multi-home.
Suresh Krishnan, not as AD, but just wanted to add another thing to the challenges. That's the congestion control, which was not listed as a specific one, but I think it's very important to look at.
Yeah, I did try to include that under where I was talking about flow control for congestion, but it's not. I mean, it could be a 12th as a separate line if you like.
Rick Taylor, just in one of the problem statements, I think it was early on, you said it's very difficult to discover the quality of the link across end to end. Yeah, that's a big issue. But to handle the first one-hop link, which is commonly the bottleneck in.
Yeah, that's part of why it's a lot easier to solve it to your provider's edge.
Dynamic link exchange protocol is just leaving MANA. It's with the ISG at the moment, and that does solve that problem.
Right, that's what I'm saying. It's a lot easier to do if you're talking about like one hop on each link. It's a lot harder to do if you're talking about off into the internet.
I agree, but the building blocks are starting to arrive for that. So
cool. Any other clarifying questions?
Those were.
Is this only for clarifying questions, or
yes, we're just doing clarified
there's
questions. Discussion will be later.
Yep.
Okay, next presentation.
Who is next?
I think that's Mingwei.
Mingwei. Yeah.
Just a minute, Mingwei. It's you, I hope.
Yeah.
I don't want that. I want this. I want this to be big.
Yeah, we're gonna have to do the same thing. And now full screen.
There we go.
Okay. GIE tunnel bonding solution now is a single operator solution. Next slide. For each link between the peering devices, a GIE tunnel will be set up, and all the GIE tunnels are bonded together to form a logical connection between the peering devices. And the home gateway will conceal the composing GIE tunnels to the end users, and the subscriber will treat this bonding connection as if it is a traditional IP link. Next slide.
Here. Just do the arrow.
And a standardized coloring mechanism is being used here to achieve offloading mechanism. So the packets colored as green color will be forwarded through the DSL GIE tunnel, and the packets colored as yellow will be forwarded through the LTE GIE tunnel. Enter the egress, the packets will be reordered according to their sequence numbers. In this way, a per packet load balancing mechanism is actually achieved. A standard GIE tunnel is used to encapsulate data packets. You can see the sequence number is being used to insert into every data packet. So according to this sequence number, the packet order can be restored under the egress. Both IPv4 and IPv6 are supported. And users' IP packets will be encapsulated as GIE packet, which in turn is encapsulated in an outer IP packet. In this way, this actually provides an L3 overlay. For the control plane, a new GIE protocol type is assigned. The number is B7EA. This actually forms a GIE channel. Over this channel, the control messages will be transmitted. A family of message types are defined. The interesting thing here is that all those control messages will be transmitted using the same GIE tunnel as the data packets. Here is a figure to show the procedure of the tunnel establishment. After the boot up, the home gateway will get 3 IP addresses. E for LTE GIE tunnel endpoint IP address, and D for DSL GIE tunnel endpoint. The third one is G, which is anycast IP address for a group of aggregation devices. And home gateway will send out a tunnel setup request message to G, and the outer source IP will be E, so that the aggregation device will learn the IP address of E and respond a tunnel setup accept message to E. And in this message, the IP address of the real destination of the GIE tunnel will be included as attributes. Also, in this message, the session ID will be included. After the home gateway receives this message, he will successfully set up the LTE GIE tunnel. After that, the home gateway will again to send out another setup request message to the real destination edge. And in this message, the outer source IP is included, and the aforementioned session ID is also included as attribute. So the aggregation device will reply the setup accept message to D. So when home gateway get this message, it will successfully set up the DSL GIE tunnel. Okay, that's it.
So Nick, do you want to come up?
Can I ask a quick question or?
Clarifying.
Okay, I mean, if you have a clarifying question, yes, but we're about to do a deployment presentation on the same solution. So if it could apply to both, you should wait.
Yeah, maybe. So can you maybe tell me what is the key difference between this approach compared to a mobile IP based approach? In that there's a signaling protocol, there's a data plane protocol, right? Data plane, right? Here you replace the signaling protocol with your GRE control channel. You call it you can give it any name, but it's a signaling protocol. You're telling the peer, set up a path, add a link, add this route, but later it's all to the data plane. So what's the difference?
Is mobile IP solution using coloring mechanism?
Sorry?
Coloring mechanism.
What coloring? Coloring is about, it's a routing decision. You have flow. You do a per packet load distribution or a flow distribution. It's a routing policy.
I think, if they're essentially the same, then for purposes of this BOF, presenting either one of them is fine. I mean, the idea is to give a flavor of the solutions and then discuss if we want to do work on this. I mean, so why don't we keep going? And
Chair noting, we have heard that there are multiple building blocks other than the building blocks on the presentation schedule for this BOF, and we can talk about those during the discussion phase, which we are now taking time away from. So
Nick,
go.
Okay, so deployments. So we have a deployment in Germany. First of all, we started basically with the development in 2012, and we had a bunch of requirements for that kind of product. It is basically in deployment in Germany. Goal was to basically offer more bandwidth for residential customers independent of their fixed line bandwidth. So it should apply to customers with very low bandwidth, also to customers with very high bandwidth. So everything between 1 megabit and 100 megabit access.
We're getting some comments on Jabber that they can't hear you. So maybe get a little closer to the mic.
Closer to the mic. Well, it takes the mic.
Bring it up a bit.
Okay. So
if you look on the product itself, it's just another access for us. So there's no difference whether you book in price, whether you book only a fixed line or hybrid access. So the base price is exactly the same. We are offering currently up to 200 megabit DSL vectoring and LTE, and the plans are to go up to 550 megabit in the future. Customer base end of 2015, roughly 155,000. As I said, the development started in 2012. Rollout in Germany was 2014. And we are also looking on other NatCos in Europe. So there are 5 additional NatCos which will basically offer the service either in the future or starting the rollout now. So product overview, it's basically one contract covers the whole solution. So you get a contract from DT, and that covers basically the hybrid as well as a fixed line. So the requirements, I think that's important. So first of all, one requirement was to make the solution available for all clients in the home network. So that would mean it should work without any changes on the clients, because we have clients like television sets and IoT devices and so on, which we simply can't control. Support for TCP and UDP. So because we already saw that there might be way more UDP traffic in the future, things like Quick and so on are coming up. It should be also possible that a single session basically consumes the full tunnel bandwidth. So a customer goes from a single device to the internet and he has 100 plus 100. The session should be able to handle 200 megabit, either for TCP or UDP. Support for IPv4 and IPv6. That's clear from our point of view. We see still a lot of IPv4 traffic in our network. Nevertheless, the network itself, our core network, supports also IPv6, and the tunnel itself is an IPv6 only tunnel. So we tunnel everything over IPv6. Cheapest pipe first. Fixed line is more cheap than the wireless, of course. So first of all, we put traffic on the fixed line. If we exceed the capacity, we put the remaining traffic added to the mobile interface. And if we have more capacity available on the fixed line again, we move it back without any session interruption. Bypass traffic, certain traffic shouldn't go into the tunnel. Some traffic, for instance, multicast for the IPTV, voice traffic and so on, should be basically routed either over the fixed line interface. And another thing which is quite important, over the top solution. So we want to decouple the solution from the underlying network, from our core network component, so that we are able to use it without modifying any networking node we own in our infrastructure. Why? That's basically the picture, how we are deploying it. We are at the moment in a process of migrating this aggregation BRAS LER boxes into a single box. And if you roll out a product like hybrid, you do not want to do any changes to the existing kind of legacy network. So implementation details, I mean, we started 2012 with a development, deployment in 2014. If you look on, for instance, state of MPTCP and things like that, which we already took into account, but those solutions were simply not able to fulfill all our requirements. So that was the reason why we took the path with the GIE and choose a partner for that. As I said, the tunnel itself is an IPv6 only tunnel, and we tunnel everything over that kind of tunnel to a device which is placed on one of our network edges in Germany. We could also easily put it into a data center. Sorry, handling wise for the traffic, we only send best effort traffic on the tunnel. So higher quality traffic, for instance, for voice or TV and things like that, are natively sent over the fixed line interface, because the service areas for that are also sitting in the fixed line interface. So it's a fixed line network. So there's no point in sending it over the tunnel itself. Nevertheless, the user and we are able to have some exceptions, so we can add policy rules for certain traffic to go over the tunnel. And the user, if he is, for instance, a gamer also, and says, okay, I fear that, that if you send the gaming traffic over the tunnel, I want to have it natively sent over the fixed line interface, he can do that. So there's a possibility to configure that. What we also foresee is, at the moment, we are only doing bundling of the interfaces, of 2 interfaces. The solution itself is not specific to 2 interfaces. We can easily extend it to 3, 4, 5 interfaces if necessary. And we see also other use cases, for instance, redundancy. So if you have like wireless plus and fixed line link, and the fixed line link goes down, that you basically put all the traffic to the wireless link. also, of course, without any service interruption at the customer side. And that's just one picture how the interface for the home gateway looks like. That is the example for the bypassing. So you can basically define a bypass based on IP addresses, on DNS names, also on certain diff-serve markings and so on. And that's basically available to the customer. Yeah, and here's some additional information. Some is in German, others are in English and referring to the IETF drafts. And I think we already gave an overview about the solution, the details of the GRE extension we are using. Questions? I think that's all I have. I hope I was.
Sung Hoon, could you come
in
up,
time.
please? And any clarifying questions on this one?
Yep, sounds good. Thanks. Oh,
Let's get on and get some slides up anyway.
Hello, Clement Trumper. One easy question. The slides are not on the IETFers app. Will you give them out later, or is there?
No, I think they should be there. I mean,
I just got it down from the meeting materials.
Yeah.
Those are the slides I'm showing.
Okay.
so that's an IETFers app problem.
Okay.
so
We did do an up.
the slides are available, and there, in fact, are more slides than I showed.
We did do updates
second
on
and
both of
final
these like
question.
5 minutes ago. So
Okay. Cool. Thanks.
maybe that caused a problem.
Second and final question: how open is that standard? Do you only support a single CPE from a specific vendor, or will you open that? Will that change?
Yeah.
Let's see.
So our general approach is our network in Germany is open to all end devices. So you can buy to a store, buy a third-party CPE and connect it. That works at the moment only for the pure fixed line network. I mean, we have published here the GRE extensions and IETF and so on. And the general assumption is that we will see more CPEs in the future as well. So we do not basically have any restrictions in terms of you are only allowed to use a certain CPE or something like that.
The solution has been described in an internet draft, and we have submitted it for independent through the independent submission process for publication. So the actual protocol itself is entirely open if you wanted to implement it, for instance.
So it's in sync with things we are doing for the fixed line only.
Hello, this is Song from KT, Korea Telecom. I will introduce about the KT's commercial service about the mobile MPTCP proxy deployment, which is called GigaLTE. And actually, I presented this presentation in the IETF 93. And actually, we already started this kind of commercial service from the June 2015. And this service called GigaLTE, and also known as GigaPass or multipass mobile MPTCP proxy. And KT just provides this kind of service to the premium users, which uses the more than about the $50 US dollar a month. And we just wanted to make data speed up and make a seamless connectivity between the LTE and the Wi-Fi. Actually, we can get a speed theoretically more than 1 gigabps. As you can see here from the LTE side, 3 carrier aggregation, we can achieve the 20 megahertz bandwidth to the 300 megabps for the LTE side. And the Wi-Fi, we got a 2x2 MIMO. We can achieve the 867 megabps for the Wi-Fi side, and we can aggregate these two type of different kind of interface. We can get a maximum 1.17 gigabps in theoretically, but actually in the best space, I mean in the very tuned space, we can get almost 850 megabps by using the smartphone. So we have some gateway, which is called in here mobile proxy, and we collaborate with this kind of service with the device vendors like Samsung Electronics and Electronics. Now we have 11 types of models in service, and actually this year June, April, we export this kind of service to the Turkey Telecom, and they are using this kind of service in the air. So this is a very simple status of the deployment. And actually, we have a multipath TCP proxy gateway, and we support all kind of application which use the TCP, and we aggregate multipath TCP in the multipath proxy gateway, and it is changed into the TCP session to the original source internet side. So actually, we are using the multipath TCP RFC 6824 comparable, and there is some kind of open community to develop the multipath TCP kernel in the Linux. And the first time we used the 0.89 version, but now we are upgraded into the 0.90. And the two subflow, basically the LT is the primary, and we can use the MP capable signal option of the MPTCP to the LT side, and we can join the Wi-Fi subflow to the between the UE and the mobile proxy gateway by using the multipath TCP option MP join. And we also use the other kind of RFC standard, which is called the SOX version 5, RFC 1928 itself, and the 1929 for the authentication for the SOX. And all the traffic coming from the UE to the gateway or vice versa goes through the our multipath TCP proxy gateway. And also we support the UDP, but we does not enable the UDP service on our gateway now. Just implemented the UDP service for the option. So just for the users, just press the button on the, as you can see in the Android menu up there. So there is a GigaLT menu there is the example of the Samsung Galaxy S6 maybe. Just turning on the GigaLT menu, and then they can use the multipath TCP proxy services. So this is the diagram of the topology of our gateway deployment model. So left-hand side is the UE, and the right middle center side is a proxy gateway called MA gateway, and the right side is the internet contents provider of the everything. So first time UE tried to obtain the information of where is the MA gateway. So it is defined in the internal in the UE side of the domain name, for example, gigalt.kt.com. So they try to make a query to the DNS server and get the IP address and the port information, IP address of the MAP. That is the some controlling function of the MA gateway, and that at that time the UE just tried to query the where is the MA gateway. This procedure is proceeding when the user turn on the GigaLT menu, only one time, and then the MAP select one of the MA gateway. We deploy the IP address and the port information to the UE, and then after that time, the UE application make a session. All of the traffic goes through the MA gateway by using the SOX version 5. So we and then the if there is the Wi-Fi coverage in the UE side, it is automatically turn on the automatically make a secondary session of the Wi-Fi. Then the traffic all from the internet side to the UE and vice versa goes bypass to the MA gateway, and then all the service can be using by using the aggregation. So this work is done by the MPTCP working group basis, and we will do some improvements on the working group. So that is all of my presentation today. Okay.
I have a clarification question on the slide. Is the session actually getting terminated at the device because the device has MPTCP support on the kernel, or is this actually a proxy that's running in user space?
Sorry. Actually, in the left bottom side, there is the Android architecture, and there is MPTCP kernel on the Linux side, and the Android framework, and the proxy agent up there, and the UE applications.
Is this right now deployed on clients?
Yeah, already we deployed that. Yeah, in Korea Telecom version of the Samsung and the LG Electronics.
Correct.
Tommy Pauly, Apple. So just want to clarify, because you're talking about how we always do the capable over LTE and then the join over Wi-Fi. So is it not possible, like if you don't have LTE coverage, to start a flow over Wi-Fi and then kind of add a cell? Or you only want it for aggregation, not for failover, essentially?
Yes, actually, we have a device specification for the device vendors, and we make LTE as a primary because in Korea we have a nationwide LTE and the 3G coverage. So
But if for some
everywhere.
reason you couldn't get it in the room you were in, you just couldn't use the
Yeah,
this.
actually, if there is no mobile coverage, the GigaLTE menu automatically turns off, and the only works on the Wi-Fi or nothing. Okay.
Shrigand, Cisco. So one quick question, like, do you use the SOX? What do you use the, why do you use the SOX protocol for? Is it for signaling the application peer's IP address, or why do you use SOX in this approach?
You mean that why we use the SOX?
Yeah. SOX
Actually,
interface.
because it is very, Actually, there is some kind of deployment model for the mobile MPTCP server on the middle, but that is the best one we are thinking, and we can transfer some kind of subscriber information in the middle of the authentication of the SOX, and all the traffic goes through the goes through our gateway.
But the proxy is not using that information. It's mainly for signaling it to the mid-level gateway, not to the aggregation.
Actually, in the just TCP or IP information, we don't know which one came from which user. So we obtain some information with the encryption in the SOX protocol, and we got information about that.
One more quick question.
We've got
Now,
to-
those
we've got to move
continuing
on, 'cause
questions
we're
are
way
offline.
behind.
My name is Yoshi Nishida from G Global Research. So I have very simple clarification questions. So in this proposal, in this architecture, you are just using 6824 RFC, and you don't use any extension that we have been discussing in the MPTC working group, transparent mode or plain mode, something like that.
Yeah, no, just using the 6824
And then
compatible. Yeah.
any plan for switching?
We will do that after the next version of the RFC. We will do that, but now in the middle of the progress.
Okay,
I think. Yeah.
Please do send additional clarification questions for this to the banana@ietf.org list. Thank you.
Thank you.
And thank you. Does this still work? All right, I got 10 minutes. I'm going to do this in 2 because we're running way behind. We basically have the same motivation here. This is more or less a replay of the ANRW talk. Who saw the ANRW talk that Miria did on this? Okay, for everybody else, we'll do this very quickly, and you can come and talk to us about how this works a bit later. We have essentially the same motivation. The motivation was a student came into our office and said, yeah, I want to do multipath TCP, but for UDP. And I said, congratulations, UDP is already multipath. You don't have to do anything. Here's your grade, get out. It's got an architecture that looks like basically all the other architectures. You got 2 bonding gateways, you split over access. This was actually a joint project with Swisscom, who actually does have an MPTCP proxy-based solution deployed right now. They were looking at what they could do for IPTV as well. So there's this provider-based provider-hosted services over here on the side. We decided, because simpler is better, we decided to sort of direct the student in the way of coming up with a very, very simple solution to this. And there's essentially a more or less linear control system with a control parameter here that just figures out, based on the traffic mix, loss rate, so on and so forth, how to balance things from DSL to LTE. The goal here is primarily to fill up the DSL line and then go over to LTE just for cost purposes, right? You could actually tune this system for other things. There's some weight increments, there's some weight decrements. It's basically sort of like, you know, tunnel congestion control and tunnel balancing for non-congestion controlled traffic. We were in an experiment, it worked. Here's some graphs. So basically what we did is we had him search through the parameter space for the 2 parameters that tune the thing, and he found for this media traffic with a couple of TCP flows over on the side that it actually worked relatively well. Left to the future, here's some more graphs. One of the things that you have to worry about here is tuning the parameters so that the TCP cross traffic gets enough of a chance to increase its window without being sort of like pushed off and onto the LTE by the constant bitrate UDP traffic. This is actually a little bit of a challenge going forward if you use something like this. The tuning for these parameters tends to be specific to the TCP congestion control and how it reacts. So these parameters would probably look different for BBR than for cubic, for example. So what we didn't do is any sort of standardizable or deployable framing for this, right? So the idea is you just have these some information, some loss information that gets communicated back. So there's a feedback channel on the outside of the tunnel. Also on the on each tunnel packet, there's sequence number. Because we do reordering, we'd actually like to be able to take that off, because you don't necessarily need to reorder media traffic, but you do want to reorder traffic for a TCP that's going to react badly to it. So it'd be nice if we had sort of a reordering insensitivity bit, which I've started calling RUTRO, like in the Scooby-Doo sense of RUTRO. I don't know what the RU for that is yet. I got to backronym that a little bit better. And then we'd actually want to sort of standardize, if you have something like this, it actually helps to have a feedback loop where the two tunnel endpoints are actually measuring the conditions of the links that they're running over. So this is something that when you're on a single provider network, this information would be provided by, I'm sure there's BBF control loops for this on DSL. I don't actually know anything about them. But if you're running over, at any point, if this tunnel traverses anything that looks like the internet, you need to have pretty good information about the losses and the conditions on the outer tunnel in order to be able to have the outer control loop to tune the balancing. So that was the 2-minute version of this. If anybody has clarifying questions, come and see Miri or I afterward. We're interested in continuing work on this. We'd have to find another student. Yeah, I don't think we should take any questions now, because we'd like to get to discussion of this space. So, Dave, thank you very much.
Okay, so inside the pink square, I take it. Yeah. Yeah. Okay, very quickly, I'm Dave Allen. I'm the co-director of wireless wireline convergence efforts at the Broadband Forum. And because we deal with fixed access, we're sort of one half of the equation in terms of looking at hybrid access. And we've actually been doing this for a little while now. Most recently, we published a document called TR 348, the exact title of which probably will be on the screen in a moment. Okay, there we go. Next slide, please. Yeah, of course. Yeah. So there's actually a hyperlink on the slide if you want to read the document. It's focused on a converged operator. It's assuming it's someone that has both wireless and wireline access and wishes to do a service that combines both of them. It covers an awful lot of preliminary ground in this space. The use cases and motivations, and just to expand on that a bit, there was 3 key use cases that came up during our discussions of this. The first, interestingly enough, was fast fulfillment. Simply the notion that I could FedEx you a piece of CPE, you could plug your home network into it, and you would be up and running, and at some later date, a truck would turn up and finish setting up the other half of the equation to connect you to the fixed network. The other, of course, was increased bandwidth in terms of wanting to have the maximum transfer rate for an individual flow being the sum of the bandwidth coming out of the house. And finally, it was reliability was the third part. Now, some of this is actually being driven by regulatory pressure in terms of the minimum bandwidth broadband requirements, and plus the fact that the economics of deploying broadband, for example, in hard to serve rural areas is a bit of a challenge. So in places where it is difficult to pull fiber comparatively deep in the network, because the DSLs themselves are getting progressively shorter and shorter reach with higher and higher bandwidth, the notion is you could actually do a hybrid access and have a more economic approach to meet regulatory bandwidth requirements in those areas. So we go into that aspect. We sort of laid out some terminology, discussed some of the potential approaches, the architecture. Now, we discussed both a single-ended proxy and a double-ended proxy. We will not be pursuing the single-ended proxy going forward. It was simply in the document for completeness, but there was no interest in it simply because it became somewhat harder to do policy from the network side when you're trying to do the actual sum of the links. I mean, if you're going to do sort of a virtual bonding interface, you need to actually have the double-ended proxy to make that sort of approach work. But for all practical purposes, TR-348 is a framework document, and that moves me on to the next slide, which is where we're actually getting into the meat of what we are doing, which is Working Text 378, which is the hybrid access nodal requirements. Now, to understand what we are doing, the Broadband Forum is not a protocol house. What we do is we take stuff from the IETF and the IEEE. At the file layer, we deal with ETSI and the ITU, and we try and assemble this stuff and sort of sort out some of the issues to make it work as a system. And we also don't do a very good job of picking and choosing, so we actually have 3 approaches that we're looking to document, all of which that are based on work that is currently progressing here in the IETF. We have an MPTCP-based solution. There's an awful lot of interest in the plain mode draft that currently is an individual submission in the MPTCP working group. The overlay tunnel-based, as described in draft Zhang that you just heard about, and network-based tunnels, the 3GPP operator case described in draft Molly. But we're going to be focusing more on the deployment and operational issues for these approaches. And that is we're going to be trying to define a policy model, which, as you can imagine, given the disparate economics of radio and wireline, is going to be sort of interesting, because we're going to be covering both failure scenarios, probably different quotas at different times of the day, etc. That's going to be on the basis of the carrier participants in the Broadband Forum to give us, much stronger requirements in that space. Performance measurement and, of course, OAM issues. Sorting out some of the addressing stuff in this is going to be interesting. For example, IPv6 prefix delegation when potentially I'm exposing 3 separate networks or 3 separate interfaces to the home network. There are definitely some issues there to be worked. And there's a whole lot of deployment scenarios we need to consider. We are looking at both V4 and V6. We also have some carriers that have NAT devices that would be deployed between the proxies that will provide us some challenges, and maybe some solutions don't necessarily work. We are on a tentative completion schedule for Q4 2017. We'll see if we hold to that given the rather ambitious list and, of course, the work we wish to be able to properly reference and synchronize with going on here. So that's about the summary of the state of the Broadband Forum at the moment. And again, do you want to shift to the general discussion or do a quick, any clarification?
Are there any clarifying questions on this presentation? Okay, let's assume not.
Okay.
So if you just want to put that mic back there,
Yeah.
give me the little widget, although, just so we can return it. It's 2:30. We have half an hour. And we'll allow open mic for discussion for about 20 minutes, and then we'll try to see if we can reach any conclusions. So have at it. What do people have to say?
I'll be short. It's Aaron Falk. Oddly, I sat through an hour of this before I realized that I built something like this 20 years ago. And I mean, the direct PC system relied on exactly this kind of finagling in order to make a unidirectional satellite link bond with a terrestrial dial-up link. I have recently learned and was surprised to discover that there's actually an enormous number of users of satellites for internet access at the fringe of the internet. And so I think that it would be very helpful to make sure that big disparities in latency is included in the scope of what you're looking at, because
I could have
latency
happily
causes
included
all
that
sorts of havoc.
as item number 13, I guess,
Yeah.
at this point. There are a lot of issues here, and I tried to hit the big 10, but that doesn't mean there aren't 15 more. Yeah, and latency is definitely, and it has to be taken into account when you decide whether to bond at all.
Rick Taylor, that's a massive +1 for me. I was about to say exactly the same thing, particularly with SATCOM links, where this kind of bonding is really important. Latency is going to kill you.
And one of the really interesting findings from Brian's and Maria's work was that some things care a lot about that, and some things don't care about it at all.
This is more a follow-on statement, really, as a question to the experiments that are being done with Korea Telecom and Deutsche Telekom and things like that. Is I'm working on the principle that, of course, your DSL lines and your 3G, your latency is pretty similar, so you're not really worrying about it too much. Has anyone here actually done any work with massive latency disparities between the two or more potential flows?
Apparently, Aaron.
Yeah, it sucks. Yeah, it's really hard.
Go ahead.
Okay, Jörg Ott. I have also come across a number of systems that would build something similar for the train-based internet access with 3, 4, 5, 6 parallel wireless links. We have been building solutions for those kinds of environments. I haven't seen those explicitly here, but they don't suffer from latency, but they suffer from high dynamics in terms of links going up and down quickly. Would be useful to not lose those out of sight.
David, please make our scope even larger.
Oh, I'm happy to help. David Skenazy, Apple. So first off, this is really cool. I'm really, really happy that this is going in a standards way instead of, efforts for this discussion, yes, to make this as standardized. I love it. How does this interact with other BOFs and working groups working on protocol ossification? Is it in scope, and Brian, you can tell me it doesn't matter, but is it in scope to try to allow people to keep innovating on these in this model, or is it completely out of scope?
So, personally, no hats. I would say that anything that only works with TCP is a non-starter. I would say that anything that only works with UDP when that UDP is not congestion controlled is a non-starter. I would also say that anything that has to do packet inspection to figure out whether it's quick or not is a non-starter. Yeah, that's all I'll say about that. I can't, let's talk offline. I can't.
No,
that's
I
a
agree with
really
you.
good question.
Those are really good non-starters. That is awesome.
It's also in some ways are related to our last question. I just put the questions up here, not because we're going to ask them right now, but because if people want to start talking about how they would, answer these questions, these are things we might want to reach some conclusions about later. But, this is not a working group forming BOF, right? And part of our question is, should this work be done in other working groups? Should it be done here? If it should be done at all, which are the lead-in questions to that? So
Aaron Falk again. So there's been a lot of work done, as we've heard about, and it appears to all be done by operators. And so a question that I have is whether the operators are interested in a standards-based solution, as opposed to the thing that they're building.
Sung Hoon and Nick, do you want to get up and talk about that at all? Other operators in the room are also welcome to talk. Answer that question. I certainly can't answer that for them. Answer.
I already said that we basically have an open interface in Germany, so we are of course interested in standardizing it. So it's on our list. The important thing is that it fulfills all of our requirements. So I think it was said earlier, so a TCP only solution, for instance, wouldn't work. So we want to have really a solution which is able to carry all protocols, including UDP, including QUIC, potentially including RTP and so on. And I would like to have a solution which supports all those protocols instead of having like one solution for TCP, one solution for UDP, one solution for RTP, because then I have to take care on all the signaling between the different proxies and so on in terms of upstream and downstream bandwidth and stuff like that. We looked earlier also when we started with the project in a multi-box solution. We have a single box now. One of the reasons is that we on a single box are able to know how much bandwidth we have available on the different interfaces, and we do not have to signal those kind of information between different boxes in the home network.
I have a follow-up question for you. Are you okay with not being the one who controls which packets go over which link?
not controlling it.
Yeah.
No. So we want to have some control, but we are also open that the user has some control. So we have kind of default configuration where we pre-configure what packets are going over what kind of link. Only also to make sure that nobody is basically fully deploying the LTE instead of using the fixed line and so on. On the other hand, we are flexible enough to allow the user to send certain traffic on certain links.
And you recognize if there are other operators in the same picture that they may feel the same way.
Yeah.
Go ahead.
I'm Rolf Winter. So what I heard was that the GRE stuff is going through independent stream. What I believe is that the MPTCP working group is going to pick up the proxying thing. So we are already on our way to standardize this stuff. So I guess we don't need a working group if the solution's already being progressed. I don't know what's happening to the MIP-based thing, but
I don't think it's been fully decided, and maybe we can get Miria or one of the MPTCP chairs to get up and say if there's newer information. I don't think it's been decided whether MPTCP will or won't do the proxy, but I think they were not going to do some of the signaling and stuff for the solution. But I wasn't even, you know, I'm not privy to all those discussions.
Right,
so Miria's getting up to answer that.
But just, I mean, you can answer this, but even if they don't pick it up, I don't think they would be happy if somebody else picks it up if they decided to not pick it up for a good reason.
Well, let's have Miria comment on MPTCP. The MIP is being done in DMM at this point, and the tunneling-based solution, like the GRE one we talked about, is not being done anywhere at this point. It's an independent draft. But well, I mean, it's not an IETF standard. It's just, I mean, we wrote it up and we tried to submit it to the IETF quite a while ago, and we're told we couldn't because of the work that was going on at the BBF. And now we're trying to bring it to the IETF as, you know, part of this effort. But anyway, Miria.
So MPTCP, we postponed a little bit the discussion to see what's the outcome of the SPOR first of all, but then it's also not fully in the charter, and what might be in the charter is like documenting some operational guidance with it. But if it's about signaling information and extending the MPTCP protocol, that's a bigger discussion. And like I would be much happier if we could find a solution where you signal this information independent of MPTCP, because it's actually not specific to MPTCP and it can be used for other solutions as well.
Right, and it's not only that you're going to do like TCP to MPTCP or MPTCP to TCP, but if you're going to link these together, you need some way to actually pass what the final end node of the TCP is going to be across. And I don't think that's currently specified in MPTCP, unless I'm missing something.
Right, but I believe, so we were both in the MPTCP session, and I think I had a very different impression of the end of the session than you did, kind of. Because a lot of people said, okay, let's pick this up. It's kind of in the charter because they talk about proxying in the charter as well. And if you read the charter in a certain way, then it's inside of the current charter. And we'd rather have it inside of the IETF than just having people deploy it because it's well defined. It's kind of a private network. You can do whatever you want in principle. So let's rather have it going through the IETF.
I mean, all we're trying to get for the last question here is like advice for the ADs about what work we want to do. And I think the question of where we want to do it is not, I mean, we will be talking about that after. If there's agreement, there's work we want to do it all. Shresh, you want to jump in line? John is next, by the way, but you can jump.
I already told him it's my intro. So, Suresh Krishnan, responsibility. So, okay, so if you go down the solution path, we're going to rat hole, right? Like, so I'm just like, I would like to use this time to figure out if there's like a problem that we can agree on, like try to steer that problem and try to get agreement on the problem in the room and figure out if IETF is the place to solve it. And for me, like one important thing, like from the IESG and IAB discussions is like, is this going to run over the internet? Okay, so I really want to use this time to figure out like a kind of a definition of the problem and like, you know, how it runs over the internet. Okay, so, and I'm going to let everybody have their like word, but I just want like you and Brian to focus on that.
It's pretty clear that if we want to solve a problem where there are multiple operators for those links, it's going to run over the internet by some definition. Okay, you know, whether it ends up running over the internet to an aggregation service provider or edge to edge is not clear, right? But so I guess one of the questions would be, is this an interesting problem to solve? And then, is it actually important to solve the multiple operator version of this problem as opposed to only the single operator? Is that Does that make sense in what you're?
Yeah, you can ask the question any way you
No,
want,
but I
right?
mean,
I'm-
people should comment on that in there. Yeah.
That's fine. Yes, right. Like so, but the feedback I'm giving you from the discussion on this is that like the multi-operator solution running over the internet is more interesting to the IETF to work on. Okay, just my feedback.
It's just more interesting to work on, period, actually. But Jana?
Jana Iyengar, I think you partially answered my question. It does seem like there's clearly a problem, and that's well motivated. The follow-up questions I had, one of them was, it seems like the operators are right now deploying their own solutions to this problem. What makes you, is it going to be the case that operators need to agree on a solution, or can we live in this world where everybody deploys their own solution? That's one question. Second question is this, this kind of pulling of links. Right now, LTE is being used in places where DSL is being used and so on. How long do we expect that problem from the operator's point of view? How long do we expect this problem to continue being there? As in, if we standardize something and get it deployed and it takes 7 years, is this problem gone by then?
Okay, I'm going to cut the mic line. I'm going to let Dave Allen comment, but then I'm going to cut the mic line because we want to have time at the end. So Dave, go ahead and then I'll answer as well.
Yeah, just as a point of information, we've got, I think, about 6 or 7 operators that are following the Working Text 378 stuff. So there is going to be some degree of convergence in the industry. I don't think they will uniformly adopt one solution because they have different challenges because of their existing deployment architecture. But yes, there is going to be some attempt to scope the number of solutions that ultimately go forward in the industry in terms of what we do.
Yeah, and
but to clarify my question, do you need to be working with each other in, I mean, are your boxes going to be talking to other people's boxes, basically is what I'm asking. Is there an interoperability problem here in terms of the solutions that you're using?
You mean whether Draft Mully would talk to Draft Zhang? I don't think that's an issue.
No. Whether Korea Telecom would be speaking to whoever else.
Well,
No.
I think one of the things
this
is
is like
that
a single operator
CPE
domain
is
that we're
not
focused on.
all purchased. I mean, in a lot of markets, CPE is supposed to be able to be purchased as a product. So you bring your CPE, it's supposed to work with DSL or with whatever it's supposed to work with, cable, whatever. And so different CPE vendors would want to work with
I see. So the
boxes
point then,
either in the
I see.
operator network or out. There are some people, and I've talked to them this week, and they can jump up if they want to, who want to offer that network, bandwidth aggregation service that's out in the internet as well.
So it's basically saying that here's my CPE. It will also work with Korea Telecom, and it will also work with somebody else because it implements the solutions that they use.
Yeah.
Okay. Do we then have CPE vendors asking for this to be done? Because it sounds like, again, the CPE is being deployed by the operators right now.
I mean, some of the CPE is being built by people who are working on these solutions. So kind of. I mean, I'm not sure. But let's keep going here.
If you
We're
look
not cutting in line, but okay, go ahead.
Can I quickly answer? If you look to the MPTCP draft, there's a bunch of CPE vendors on the draft which want to actually have a solution because of this.
Okay,
this problem.
sounds good. So I think it's the front.
Rick Taylor, Airbus, as a sort of operator, we're in a strange place. Our CPEs have wings on them. I want to build this. I need to build this, and it's got to work with deeply asymmetric links, and it's got to be open standards because we only want to build one end of this. Sure, we can go invent our own, but I think this is worth doing somewhere in the IETF. Whether it's this, whether we form a working group, or whether there's someone steering to make sure that all the other working groups are lined up. I think this is positive. Oh, and by the way, it's got to be IP based. You can't just have it TCP only.
Okay, and back.
Blaine McDonald, AT&T. I do see value in creating standard, but I do see 3 distinct standard possibilities. All your presentations have different applications. So single provider, multi-provider, and as a aggregation as a service approach. Would like to hear from some of the other providers that have trialed it, how much of their traffic, what percentage of their subscriber base, and what percentage of bandwidth they're actually combining, because depending on the architecture, might return on investment and how much more, from business perspectives, what we need to be looking at.
Yeah. Front.
Tommy Pauly, Apple. So a couple of the comments that we've heard recently have been about, like, yes, we do want to have whoever is deploying these proxy or aggregation solutions have control over the multiple links. And we also mentioned that this needs to work with end-to-end MPTCP and end-to-end quick and stuff. And so if we're doing work in a lot of other protocols to make them multipath, and at the same time the operators are saying we want a consistent way to be able to control those, how multipath works, it seems like that is at odds with the efforts that like an end-to-end MPTCP or quick solution would have. So I don't know if that implies a protocol level, like the path layer in somewhere in the stack that is just doing path signaling, and if that needs to be multipath aware, and maybe we try to converge the multipath protocols there, but that could be a piece of work that a new group would need to do.
Okay. Aaron, we did cut the line, so I don't know if you're bringing up a person who was already
I
in
have a
line.
Jabber comment from an area director, so
Okay,
I can sit
guess
back
you
down.
can insert it.
It's really up to you.
We'll give them courtesy if it's quick.
So Spencer asks, if you have a multi-operator solution, do you still need a single operator solution that's not the same?
I don't know that those are, I think it's possible a multi-operator solution could apply to the single operator case. I mean, it depends on the solution and whether it meets the needs of a particular operator, obviously. I think the other way around doesn't necessarily work. There are some things that are inherently single operator that couldn't be multi-operator. But like especially all the bandwidth aggregation service ones could definitely work single operator because the operator could also offer that service, right? I mean, but back.
The Kutscher. So here we have a problem where say multiple operators have an interest to like achieve interoperable solutions. So that's clearly motivation to do this work. And they're also like providing us with like concrete requirements. So it's a really good starting point. On the other hand, I would also like to re-emphasize what Suresh said. So I mean, if we do that, we should make sure that this the output will support the operator equipment really well, but like it's not constrained to be run in an operator network only. So that means no assumptions on like access networks, no assumption on where the concentrator actually lives. I think that would be really important.
Right. Even though they've been deployed on specific access networks, the solutions we presented today are not specific to particular access networks. Wim?
Wim Hendricks, Nokia. I think, is that a problem to be solved? Yes, I think because if you see how much work there is actually already going on in IETF with respect to this, I think you already see that there is something to be done here, right? If you look to how, my advice on how to do it, I would think, my personal view is that it's better to do the work in the respective working groups because there is the expertise of the protocols, right? And there is already, I think, work going on, both in MPTCP, where I'm actually part of that effort, as well as in DMM and things like that. And I think we should use those working groups because they have the protocol expertise and potentially augment that with some other expertise which is required for this multipathing, something like that. But that would be my view on the situation.
Okay, let's try to take less than a minute each, and so we can have some time for questions.
Liang from China Mobile. First, just for a bit of information, that we used to deploy the dual uplink devices in China with LTE and PON, but they're not used for hybrid access. They're just to be deployed there when the fiber infrastructure is not ready, and then it's switched to the fiber, the PON access FTTH, when the fiber is ready. But we're not doing it nowadays because we found it really not that cost effective. So given that, I would really like to see the working group given more emphasis on the scenario where we consider hybrid access of two wireless connections, for example, Wi-Fi and LTE. That might have a broader application and so on. And second one is I'm really glad that the latency issue was raised by several experts here again, because we have been in active discussion with Huawei and also Nokia offline, and also in the barb of banana of the latency stuff. But I'm slightly worried that the charter or the scope that has been presented in this BOF, I don't think latency stuff is in the scope, because latency stuff is not really a bonding issue. It's really selecting one of the best channel from the others. So I think we probably need to give it more thoughts whether to put that in the scope or we need to do something else?
I think latency has to be in the scope as part of deciding,
Yeah, it's
what to use and how to use it. And
well,
yeah.
but when you use latency characteristics to decide, it's not really to decide you should bound or not. Maybe it's really you just use the single channel for example for a mission critical service.
Right, and it may depend on, and that's some of what Brian's presentation would have gone into if we had had time for it. Was
Yeah. So come talk to me.
Yeah. Thank you.
So
5 seconds,
the
Alan.
mic was cut after the gentleman was at the mic now, and 5 seconds.
Alan Ford.
Thanks.
Damn. No, in MPTCP, I think what would be really useful for us is to get a better view of what the problems are we are trying to solve. We've already got 3 proposals bouncing around on the table. The work, the interest in this area about getting it done is clearly real.
Yep.
I don't know where best to do it, but a clear problem statement would be much appreciated.
And we had cut the line already. I'm sorry. So Brian.
Yeah. So okay. Well, that was a. So if Alan's asking for a clear problem statement, he's not going to hum for is the problem statement clear. So yeah, I'd like to actually just get a sense of the room on this first question. Is the problem statement clear, well scoped, solvable, and useful to solve? If you think so, hum now. We have to hit all 4.
Can you put a slide up with the problem statement on again?
It was the first 2 slides of my presentation. It's
Yeah.
going to take longer than we have to
Yeah,
go
okay.
get it.
Oh, okay. Clear and well scoped. If you believe, if you think you understand what's going on here and it's not boiling the moon, hum now, please. If you have no idea what's going on, hum now, please. Yeah. Okay. Yeah. If you don't think the problem statement is clear or is well scoped, hum now, please. That sounds about 50-50. Okay. I'm actually going to go. Huh? Aaron, you want to go ahead?
You got 3 hums for and 2 against.
Okay. Yeah. So it's 50-50 in Jabber as well. I'm gonna skip over the second one because there's already work being done on bits of this problem within the IETF. And if we don't have a scope, we can't actually figure out, and it's clear that there needs to be a little bit more work to figure out, where we're going to draw the box on this. We've actually gotten a lot of comments today that help us sort of like make that boundary around the box a little bit more bold and also somewhat terrifyingly bigger. But I will go ahead and ask the third one. If you're interested in working on this problem and you're in the room or in the Jabber room, please raise your hand now. Order 32.
How about the Jabber room? We getting a few or anybody?
We've got one person who's still humming.
Okay. So
Yeah.
So 30,
Yeah.
somewhere between 30 and 35.
Yeah. Order 32. I don't actually think that we can answer in 2 minutes the fourth question. I think that.
Is it worth asking the question, how many people are already working on this class of problem in an IETF context?
Yes. Yes. Thank you, Dave. Did everyone hear that question, or should I repeat it?
Well, I mean,
Yeah.
the last part in an IETF context, I mean, is uncertain. I mean,
Well, are already working on it in an
Is the banana
IETF
barb off an
context.
IETF context or not? Because
Go ahead and raise your hand anyway.
okay.
But we've referred to a long list of drafts and
Yes,
discovered there's a
exactly.
whole lot more, which
Yeah.
means lots of people are already doing stuff
Yeah,
on that.
everyone who has written or is writing a draft that addresses part of what they believe the problem is, please raise your hand now. Okay, that's about 10, 20.
No.
No.
Please raise your hand
Yeah.
again.
Oh, wow. Okay.
Yeah, maybe.
All right, about 20. Yeah.
No presence on Jabber. Just want to point out that there is work that doesn't involve writing drafts.
Yeah. Okay.
But that, I mean, if 20 people have written drafts, even more people are probably involved than that.
Yeah. So I think I'm going to let Suresh have the last word at this point because we have 1 minute.
Yeah, so I would really like these people to show up on the mailing list and try to work on the problem together. Like, because I have a fear that everybody has their favorite pony in there, like, and they just want to like make that happen. And I think that's a good thing to have. But I think we need to have a common understanding of the problem too, right? Like, and something based on the slides you showed would be like a good thing, but like a more solid version of that would be very helpful before we go into the solution space.
So yeah, so if I can make a suggestion, homework for the banana list, everybody who thinks this is important, let's get a thread started over there where the outcome of that thread is a problem statement and a scope for a potentially working group forming BOF in Chicago.
Yeah, and the banana list, if you go to the BOF description on the wiki, the sign-up information is there. So that's where further discussion will happen. And I will try to throw at least some of the stuff that I have here on my slides into a draft, like a straw man draft, so we can start having something to whack at in terms of getting a better defined problem statement that everybody who's interested feels is well scoped and understandable.
Okay. With that, thank you very much.
Thank you.
Pretty much exactly how I got this one. I learned a lot about satellites. Yeah, but I agree with Suresh's. I agree with Suresh's problem here. That if we have a whole bunch of people working on it.
So we keep the rest of tomorrow.
So especially in the case where, you know, one of the things but they have a weird IT.
Yeah, I know. Yeah. But I
So hello. Oh, Bushi's. Yeah, okay. Yeah.
Oh.
Hi, how are you?
Good. But there's a lot of interest.
Yeah.
Interest.
Yeah, yeah. So yeah, I think so people who showed up here